So now what I'm going to do is, okay, I'm going to transmit two signals, okay? Alright? So you see, we are using quadrature amplitude utility. So quadrature utility has two multipliers and an adder. Okay? So obviously one multiplier has one signal and say sine, and other one will have second signal with cosine. Okay? And then the output is coming here, output is coming here, and then this is your QAM signal. And then in the receiver side I have two demodulators, one multiplier low pass filter and a phase shifter to correct the phase, right? Okay, even if the signal is coming from the same source, because of the wire they can be different phase shift, because wire means traveling, right? So when the signal is traveling, there might be phase difference between them. Okay, so we'll correct it with the phase shifter, and the same thing happens for the second signal.
Okay, how do we tune the phase shifter?
How do we? Yeah, we just tune it, keep changing it until we get the correct signal.
How can I confirm?
We know our signal, right? So we will wait for the same signal. But in reality, we have to. This is where we'll use different kind of techniques to find out the phase of the actual carrier, and then automatically tune it. So this is a control feedback. Okay, you keep doing it until the error is 0. Okay. Now, let's see our first signal.
Bismillah, first message.
First message, okay? This is my first set. And this is my
Bismillah,
second message, okay? Now, I am transmitting it, okay? This one is for the second, and this one is for the first. If I want to get the first message, I'm multiplying it with sine, so I'm multiplying over here with phase shifted sign. Okay, let me listen to the message now. Very nice, right? Suppose there was a phase difference. It's interference, right? Can you see that? So how do I fix that?
Just hit the push.
I will fix the phase so that the phase is not different between the carrier.
Okay, engineer, this we can hear from the headphones. How about in the signals?
Digital?
Yeah, how can we
Very
identify?
nice. So you know what you so this is why you always have a period for testing. Before you actually start transmitting, you do a test. So you transmit a known signal and you see if you get the correct signal. If you don't, you were thinking how to change it. So this is what they do actually. They transmit a known signal and they receive it. In the receiver side, if they see it's different, based on the difference, they know the phase difference, and then they correct it.
Okay.
Okay. And then let's go to the second one.
Bismillah, second message. Bismillah, second message.
It's interference, right?
Bismillah,
So
second
I will try to
message.
fix it now.
Bismillah, second message. Bismillah, second message. Bismillah, second message.
Doctor, can we fix it using like the waveform,
Second
looking at the waveforms from the program?
No, you can, but that's going to be too hard, because voice message is combination of frequencies. You know, if you now, because over here you have to go and look at a time domain.
But okay, if it's a sine one, then we can do it easily.
If it's one sign,
Yeah.
then it's easier.
Yeah.
Yes. That comes back to, because nobody transmits sine wave.
I know.
They transmit as combination. So they can have a testing period where they transmit a sign and then see the phase difference and then correct.
And then correct accordingly.
In our case, we'll also use the audio signal.
In which one?
In our case, when we practice or in exam, we'll have to use an audio signal.
If you use an audio signal, it's easier for me, because you know what you transmitted, and I will just listen. So if it's correctly received, then full points. If it is not, then there is a point of discussion. If you cannot explain, then 0. Easy, right? Binary mark.
And if you can explain, you get full mark?
You get full mark.
If you can explain, and the explanation is of the beauty level of what Mohammed said today regarding that receiver side harmonics, it's okay. If it is this and then that,
Shaky.
and then that happened, and then that happened, then zero minus.
No bonus?
Huh?
If there is a minus, there is a bonus.
No, yes, negative bonus. Okay, so that's what happens, right? Okay, now second signal.
Bismillah, second message.
At least some of you might say, no, it's okay, it's working because the second signal is loud.
Bismillah, second message.
If I cannot fix it further,
Second message. Bismillah, second message. Bismillah, second message. Bismillah, second message.
now this is a very bad interference, right?
Yeah.
So the one that was before at least was better. Okay? And I know how to fix it with the phase shifter. If you tried everything and you cannot fix it, then the problem is this doesn't have, you see, even that small amount of phase is making the problem. Remember? Phi, if phi is 5 degrees, it's going to make a problem. So it should be correctly removed completely. Okay? So for that you need really good phase shifter that can even fix this 5 degrees or 2 degrees or 3 degrees. Okay? In the exam, if you cannot fix it, you tell me it's a phase shifter. I said, did you try everything? He said, yes, I tried. Then why can't you fix it? He said the phase shifter is poor quality, not the highest quality. If you give me like that answer, it's convincing answer and it's worth the whole point. But if you say that there's a phase shifter, maybe there's a problem. Maybe, khalas. Because you said maybe. You cannot say maybe in the exam. Okay? Make sense? Clear?
Okay, what if like there are two possible scenarios, but maybe it's not working, and maybe the phase shifter is not accurate.
Maybe it's not working.
Maybe-
I'll give you another phase shifter.
Alright.
Engineer, is there anything else that can be done to improve it then? Besides having a high quality phase shifter?
That's a very good question. Tune the low pass filter. Make the low pass filter exactly, but both of them are voice signal. Both of them will have the same frequency range. Okay? If I give you two signals which are different frequencies, then the low pass filter will help. Okay?
This is just not working.
Hmm?
This computer is just not working.
Really, huh?
Can you kindly tell us how we can record the signal?
I did not show you that?
No.
Okay.
was recorded.
I was taking screenshots here. If you look over here, that's message 1 in time domain, message 1 in frequency domain, carrier in time domain, carrier in frequency domain, right? I put the marker 100. Then this is AM signal 1. Red is the message and blue is the AM signal, right? And that's AM in frequency domain, right? By the way, for your screenshots, you will not use voice, because if you put voice, you will not, because it's not that clear. You will not understand. So you will use sign signal. Okay. If you look over here, that's my message signal, which is 10 kilohertz. No, 10. Yeah, 10. No, 10 hertz. No, 10 kilohertz. Yeah, 10 kilohertz. So your AM signal is 100 plus 10, 100 minus 10. Okay.
And there is in between some sort of.
Yeah, this one.
Yeah.
But this is not carrier, huh?
Yeah, but why is it like this?
Harmonics.
Yeah, but
Nothing is perfect. You know? Some
Noise or harmonics?
Huh?
Noise or harmonics?
noises are sometimes harmonics. Yes, noise can be anything unwanted is noise. Sometimes harmonics are noise. Okay, you have to be, that's how you relate them. Okay. Okay, clear? I'm going to fill it up more. Okay, so in the exam you will not, for the lab you will not use this. You will use this and audio oscillator, 10 kilohertz. 2 messages. Okay. Now I will show you how to record. So recording is, see here, this button, you see knob. If you just put it up, 1 2 3 1 2 3, and if you listen to it,
1 2 3
That's
1
it.
2 3.
sometimes you can use live.
Hello, hello, hello. 1 2 3 1 2 3 1 2 3.
Okay, that's live. Okay. Sorry. Any question? Clear?
For the exam, as we will use the audio, can we still use audio here? so that we can listen to both?
Of course, it's up to you.
And what is the
In the exam, we will
what
not
is
use
the use
audio.
for the
He
audio
said
oscillator?
it will be easy for
Or did I say it? Because you have 2 kilohertz here.
Because he'll be
You
able
want
to-
second signal of another frequency, right? So we'll use audio oscillator. Oscillator.
We have 2 kilohertz message.
You need 2 signals.
Okay.
So one of them is 2 kilohertz. You need one more. So we'll get it from here. 10 kilohertz.
But-
10 or 3 because in this experiment you need 2 signals.
Okay.
One signal is this 2 kilohertz. The second signal is coming from here, audio oscillator, because you can generate any frequency from here. Make sense?
Yeah, but how do we know the frequency of this one? We use the TTL thing
Yeah. If you can use TTL and put
and
the
connect it here.
Yeah.
Okay.
Yeah, that's fine. Remember, when you want to look over here, it's always divide by 100.
Divide by 100.
Yes.
Okay.
No. For counter, no need. But when you're doing low pass filter, connect clock. Whatever you get, divide by 100.
For only the low pass filter.
Only the low pass filter.
Okay.
Make sense? Can you go to the next BPSK?
Yeah.
Okay. Come, let's go.